Alright, welcome back guys. So in this video here, we're gonna start talking about lesson 7.2, that is estimating a population mean. We started the chapter already, discussed how to estimate a population proportion. We talk about point estimate. We also talk about confidence interval. So that's where we're gonna picked up is that in this lesson, we are gonna talk about point estimate again, and also talk about confidence interval estimate, how to estimate the population mean. So in other words, what we're looking at here is we're gonna use, so in this lesson we're gonna use sample data, and sample data we can obtain an x bar, which is a sample means, and then we use that x bar to kind of estimate mu, which is the population mean. So this is sample mean, and then this is population mean. Okay, so as far as calculating an average or the mean, you take the sum of all the data values and divide by how many there are. So of course, to get a better estimate for the mu, we want large sample size, right? However, in real life, it's hard to obtain large sample size. So what we can do is, we have just obtain a decent size sample and then calculate the mean from there. So that's all we can do. And then we obtain the point estimate from there as well. So sample mean is also a point estimate. Okay. The problem with that is, with the point estimate, it's hard to tell whether how far off we are, or how close we are with our estimate. Therefore, we need to use confidence interval, which increases the likelihood of us guessing it right. However, we have more possible values, so there's always a trade-off there. So in this lesson, we're gonna look at a new distribution as part of constructing a confidence interval to estimate the population mean. To get started with that, we need to know, we need to review a few things. That is, given a data set, how do you calculate the mean, the sample means, and also sample standard deviation or variance. So let's look at this example here. Suppose we want to estimate the mean miles per gallon of a 2011 Ford Focus. Okay, so that is a population mean. That's our goal there. We want to estimate that population mean miles per gallon of a 2011 Ford Focus. Now, what we can do, in this example here, these 16 reported values of miles per gallon based on the drivers. So this is just reported data, not as reliable, but it's something that we're given here. So what we can do is use this 16, a sample size of 16 data values that these drivers self-reported, and then calculate an x bar from there, and then that would be your estimate. And again, that's not quite accurate because our sample size is so small. We don't know the value is good or not. To get a better sense of estimate, we need a larger data set. So that's where we're gonna go next is, what if we can't get a larger data set? Can we use different technique? And that's where the confidence interval estimate is gonna come in. So in this example here, what we're gonna do is obtain an x bar, which is a point estimate, and also standard deviation, which is lowercase s. Now to do that, we use a calculator. Again, we can do this manually by hand and use the formula. And the formula S was, I think, is square root of sigma x minus x bar square over n minus 1. We could do this manually, but we're not going to do that. We're going to use a calculator to obtain this mean and the standard deviation. So in your calculator, as you remember, that was one variable stats. That's the command we use. But the first thing you want to do is you want to enter the data values first. So if I've already done this here, so under my L1 column, I've already entered all the data values, 16 data values, and then I'm going to calculate the mean and the standard deviation. So I'm going to do stats, cal, one variable stats, and I'm going to do second L1. So that's where my data is stored under the first column. So this give me the mean is 36.7 or 36.8 rounded up. The standard deviation, which is lowercase s here, 2.89. Okay, so I'm gonna go back to my notes. Okay, so I'm gonna say x bar now is 36.87 miles per hour, and then standard deviation is 2 point 2.89. Okay, so this number here is our point estimate for estimating population mean, so point estimate. Okay. So now it said that note that in example 1, a different random sample of 16 cars. If we look at another list of 16, drivers who report their miles per gallon of their vehicles, most likely, we're gonna get a different point estimate, different x bar. So for this reason, we want to construct a confidence interval to estimate, to have a better sense of how confident is or estimate. And I said that just as we did for the population proportion, that's what we did in 7.1. We learned how to do the math formally, construct a confidence interval to estimate the population proportion. That was P. So just quickly here, this is what we did in 7.1. We said that the population proportion. So let's say recall, population proportion. It can be estimated using p hat, which is a point estimate for sample proportion, plus the margin of error, and then p hat minus the margin of error. And then at the same time, we have some sense of level of confidence with this interval. And in the last videos, we discussed what that means when we say that we are 95% confidence versus 10% 95% confidence or 99. So all that was discussed in the previous video. Let's move right on to how will we do the math itself. What's the formula? What's the difference if we do the same thing for estimating a population mean, which is mu in this case. So the first thing we still need is a point estimate. And our point estimate, just like p hat, in this case we use x bar, sample means. So that's the sample means. And the sample means, it's just the means calculate from the sample data is given. The second thing we need is, we want to calculate the margin of error. Okay, and the margin of error formula is E, denoted as E equal to Z alpha over 2 times the standard error for the sampling distribution of sample means, and that is sigma of x bar. For estimating proportion, we have sigma of p hat. In this case, we have sigma of x bar. And so that's going to be Z alpha over 2 sigma of over square root of n. That was come from the distribution of x bar, and that was in chapter 6 when we discussed sampling distribution, sample means. And Z alpha of 2 is the critical value. And another thing we discussed, margin of error, that was the maximum difference of our estimates between, so maximum error between, our estimate x and the actual value mu. Okay, so that's what the margin of error stand for. From there, as you recall, we move on to constructing the confidence interval S. So confidence interval, right? So we said we take the p hat minus the margin of error, and then p hat plus the margin of error to get the endpoint. So in this case, we do a similar thing. We take the x bar minus the margin of error, and then we take the x bar plus the margin of error. So that's how we get our confidence interval. And then we say that mu is can be somewhere in there. So mu can be somewhere in there with certain level of confidence. Okay, so that's very similar what we did last lesson with estimating proportion. One problem one issue that comes up with this lesson is that now we don't know what the population mean is, and in the process of constructing confidence interval to estimate the mean, we use this sigma. We use this sigma here, which is the population standard deviation. Now, if you recall that, issues. If you recall that sigma itself, the formula for the population standard deviation, is equal to the square root of sum of x minus mu square over capital N, which is sample population size. So in the formula for sigma, we require to know what the population mean is to calculate sigma. So how are we supposed to assume that we know sigma is given if we're trying to estimate mu? So it doesn't make sense at all that we're trying to estimate the population mean, but somehow we know the population standard deviation. So in practical sense, that doesn't make sense. So we're not going to focus on example problems that where sigma is given. We're going to focus on example where sigma is not given. Okay, so we're going to say, we're going to say only focus on example that sigma is not given. Okay, so if sigma is not given, what do we use in place of sigma to make the whole formula, the whole procedure works? Well, you can guess it yourself. So sigma stands for the population standard deviation. If we don't know what sigma is, the closest value we can use is the sample standard deviations. So we can use sample standard deviation instead of sigma. But the problem with that is it's not quite the same value, so there's some sort of errors, there's some sort of uncertainty there. And that's why this whole thing, we're doing the whole process of here, it just, and that's what comes with stats is we use statistics to estimate things, make choices. So a lot of those choices come with some sort of uncertainty, but we feel a certain level of confidence, certain probability of guessing right and such. So there's always some sort of uncertainty when it comes to data value and things like that. So, but this is probably our best bet is that use S in terms of sigma there. Okay, so now the margin of error, formula now becomes S over square root of N there, and we're going to use a different critical value. Instead of Z alpha over 2, we're going to use T of alpha over 2 as our new critical value. It turns out that if we have a sample data with certain size N, then each of those samples same size N would generate different sample means, different sample standard deviation, just as this example here. Okay, so if we generate another 16 different value, we'll get different mean, different standard deviation. So each of those sample data will generate different sample mean and standard deviation. Therefore, we have a new entire distribution, and that new distribution there is going to call the T distribution. Okay, the student T distribution. And here's a little background on the student T distribution you can read on your own to kind of be familiar with that. And there's a great YouTube videos out there as well for you to just kind of watch if you want to learn more about that. But one important thing with the T distribution is that now we have this new thing called the degrees of freedom. Okay, so that's something that's come up when we use this T distribution. And it's not just a single curve just like the Z, but it's a family of curves, depends on what sample size we're looking at. Different sample size, we have different degrees of freedom, and different degrees of freedom will generate different curve. So I would highly recommend do some research on this, or kind of read up from a book, or this note here, or just kind of watch some videos. I can refer some great videos that people have posted regarding the T distribution. So that's pretty much what's going on with this lesson is that we just continue on from 7.1. Instead of estimating population proportion, we estimating population mean. With the population mean, we don't know what the standard deviation would be for the population, so we use our best estimate, which is this sample standard deviation. Because of that, there's a bit uncertainty. Because of that, we have a new distribution we work with, and that new distribution we work with is called the t distribution. Usually this is referred to small sample size. Small sample size. Okay, all right, and it's also has to come the data we select has to come from the normal distribution as well to make this whole thing work. But I'm gonna go ahead and end the video on this note, and then the next video I'm gonna go over how to show you how to do the problem using calculator approach or just doing by hand.